Hey Calculus, welcome back. Hope you all are well. Our objective today is going to be to create slope fields from differential equations. I've got the checklist on the screen. You know what to do from here. So before we get started with slope fields, this lesson and the next lesson, I actually want to do a bit of algebra review to make solving differential equations, which will be kind of the third lesson in sort of this chunk, easier. Okay, so today we're going to do slope fields. Tomorrow we're going to look at one very particular kind of differential equation, and then that third lesson will be solving full-on separable differential equations. Okay, so I'm first pausing your screen. Can you go ahead and copy what I have on the screen? All right, so after we do the calculus part of solving a differential equation, which again, we're not there yet, but we will get there not with the next lesson, but the lesson after that, we get to something like this. And at this point, it is just algebra, okay? So we get y's and x's with a plus c, and we're given this, which is called our initial condition. This can also be called an initial value problem, I have a kitty here. So we have two missions once we get to this point. The first is, hi, little kitty. Say hi. The first is to figure out what C is using this initial condition, which, will you write this as an ordered pair? This is the same as x is 1, y is -4, right? So our first goal is to find C. Our second goal is to get y by itself. Okay, so let's start by plugging 1 in for x, -4 in for y. And solving for C, okay? So -4 squared is 16, 1 cubed plus 1 squared is 1 plus 1, which is 2. So C must be 14, right? Okay, so now I'm going to plug C back in here. So I'm going to come back to my original. I've got y squared equals x cubed plus x squared plus C, which I found to be 14, right? Okay. So that was step 1, was to find C. We did that. Step 2 is to get y by itself. So y is almost by itself. I just need to take the square root. But when I introduce a square root, don't forget you need a plus or minus. So I have this, which is a problem because I'm looking for a function, see f of 1. And that's not a function because it's got two outputs, a positive and a negative for most inputs. So I have to decide, maybe you remember doing this from pre-calc, I have to decide, do I want the positive branch or the negative branch? Do that by testing your initial condition. So come back, plug 1 in for x here, and -4 in for y, and see which branch, the plus or the minus, gives you a true statement, okay? So I'm plugging in -4 for y, got my plus or minus. I'm plugging 1 in for x, so 1 cubed plus 1 squared plus 14. Well, that's 16 under the radical, which square root of 16 is 4. Well, I want -4 to equal -4, right? So I want to take the negative branch. So my final answer is y equals -square root of x cubed plus x squared plus 14. And that's the algebra part of a differential equation. All right, let's try another algebra review. Force a pause on your screen. Can you go ahead and copy what I have? Okay, so again, I need to figure out what C is and then get y by itself. I'm seeing like this natural log, so do kind of think ahead. What is the inverse of natural log? The inverse of natural log is E, okay? All right, so first let's come, and I really do like to write this as an ordered pair, 2, 0, so I can see really clearly what's x and what's y. So I'm going to come in here and plug in 0 for y and 2 for x. Okay, so here I get ln of 1. Well, ln of 1 is 0. So this is ultimately going to give me that C is positive 1/2, right? So there's step 1, I found C. Now step 2, come to your original, rewrite it with the C that you found. So ln of the absolute value of y plus 1 is equal to -1 over x plus 1/2, right? That's what we got for C. And now I want to get y by itself. So I see, okay, first of all, y is trapped inside this ln. So let's exponentiate both sides. If I do e to all of this equals e to all of this. So what was the left and the right side now become my exponents, okay? So when e and ln are right next to each other, those cancel, and the left side just becomes absolute value of y plus 1, don't drop that absolute value, and the right side just becomes e to all of this. Okay, all right, now, next I need to get rid of the absolute value. So I can drop the absolute value on the left if I add a plus or minus on the right. That's what absolute value means, right? And then I need to get y by itself, so subtract 1. So y equals negative 1 plus or minus e to the negative 1x plus 1 over 2. But do keep in mind we cannot have a plus or minus in our final answer, right? So let's come back to our initial condition, 2, 0, and see which branch, positive or negative, gives me a true statement. So plugging in 0 for y, 2 for x. All right, so negative 1/2 plus 1/2 is 0, and e to the 0 is 1. So would the true statement be negative 1 plus 1 or negative 1 minus 1? The plus is what would give me a true statement here, right? So my final answer is y equals negative 1 plus e to the negative 1 over x plus 1 over 2. All right, let's try one more kind of algebra review problem before we look at slope fields. First, pause on your screen, go ahead and copy what I have. All right, so let's first write our initial condition as an ordered pair. This is 0, 20. I see that I'm using x's still, but instead of y's, I'm using capital B, so just kind of keep that in mind. I also want to remind you of some log rules. Remember that when two logs are separated with addition, I can bring them together using multiplication, because logs are the inverses of exponents, right? So when I have same exponents or same bases, and I want to multiply the bases, I add the exponents, right? So it's the opposite for logs. Similarly, if I have one log minus another log, I can bring those into one log using division. Okay, so you might want to write that down if that is not familiar from Algebra 2 or Pre-Calc. You'll need those, okay? All right. So let's come back here. So I'm going to plug in, let's see, 20 for B and 0 for X, okay? So here 100 minus 20 is 80. Absolute value of 80 is still 80. So I'm getting that C is ln of 80, because 0 over 5 is just 0. All right, so there's step 1. I found C. Now come back to your original. Oh dear. And rewrite that. So ln of the absolute value of 100 minus B is equal to x over 5 plus C, which is a negative ln of 80. Okay, now I want to get B by itself. Now notice that this is a little bit different from the last one because I have 2 ln's here. In this one I only had 1 ln. Okay, so if you have more than 1 ln, get all your logs on one side, everything else on the other side. And I would really recommend, it's going to make your life easier in the long run, if you look at, try to think ahead and look, what am I trying to solve for? I'm trying to solve for B. It's in this log. Let's get the logs on the side that would make this log positive, okay? So let's move all the logs to the right-hand side, okay? So I'm going to move this log. It becomes ln of absolute value of 100 minus B. This log stays. And I need to move this. Okay, why do I want to get the logs by them or on one side together? Well, because now I can go ahead and combine these using that quotient rule we were just talking about for logs. So they're separated by subtraction. I can bring them together using division. Okay, Why did I do that? Well, now I can exponentiate, okay? I can't exponentiate. I cannot get rid of the log until I have just one, okay? 2 don't just magically disappear with 1 e, and I can't do 2 e's because I can only do one thing to each side, right? Balance out the equation. So I'm going to exponentiate both sides now. Whoa. Okay, so the left side just becomes e to the negative x over 5. The right side, the e and the ln cancel, and I have absolute value of 100 minus b all over 80. All right? Okay, we're getting close now. I'm trying to get b by itself. So next, we want to multiply both sides by 80. So I'm going to get 80 e to the negative x over 5 equals the absolute value of 100 minus b. Next, I need to get rid of the absolute value, so we'll plus or minus on this side. We can drop the absolute value on this side, and then I need to subtract 100, so negative 100 plus or minus 80 e to the negative x over 5 equals negative b, and then finally divide everything by negative 1, so 100 plus or minus 80 e to the negative x over 5 equals positive b. Okay, again, I can't have that plus or minus, so we're going to come and check the point 0, 20. So when I plug in 20 for x, 0 for x, I get e to the 0, so this becomes 1. 80 times 1 is 80, okay? So do you want 100 plus 80 or 100 minus 80 to get my true statement of b being 20? We want 100 minus 80, right? So final answer, 100 minus 80 e to the negative x over 5 equals b. And that's our final answer there. Look at all the algebra you just did. There's zero calculus there, right? And this is why I want to do this review, because the calculus is literally 2 steps. And I don't want you to get too overwhelmed with the algebra once we get there. I want you to be able to focus on the calculus once we get to solving differential equations. All right, so one method of solving differential equations is to first create what's called a slope field. And there's not a whole lot to it. So I've got a differential equation because I've given you a derivative and an equal sign, an equation, right? And what I'm going to ask you to do is to draw a slope field that represents this differential equation. And I want you to draw the slopes at each of these points. Now, for your assignment, you're going to really need to copy these carefully or find a place where you can print them, okay? This is one where we really do need the graphs. So find a place that you can print ideally, otherwise just be really careful with these graphs and draw them very precisely. Okay, so we're going to pick one of our dots. I prefer to start at the origin, okay? So let's say here, let's come to the origin here. So what I do, I'm going to do dy dx at 0, 0. Okay, so I'm going to plug in 0 for x and 0 for y. So I get 0 minus 0, which is 0. So I come to that point, 0, 0, and draw a slope of 0, which looks like that. That's it. Okay, and we fill in the points. So let's do another one. Let's do this point right here. So this point right here, each dot is 1 unit. So let's do dy dx at the point 1, 1. Well, if I plug in, I get 1 minus 1, which is 0 again. So here, at 1, 1, I need another horizontal line. And by the way, isn't that what you're going to get at 2, 2 as well? And also at negative 1, negative 1. Right, anywhere y equals x, you should get slope of 0. Okay, so slope of 0 is horizontal. By the way, if you got an undefined slope, you can either leave it off or do a vertical line. Okay, let's do another one. Let's do this point right here, 1, 0. So I do dy dx at 1, 0. Let's see, I'd have 1 minus 0, which is 1. So I want to do a slope of 1, which should be 45 degrees, right? I mean, it does not have to be perfect, okay? let's do this one. Let's find it at 2, 0. So that's going to be 2 minus 0, which is 2. So when I go to draw that, I just need to make sure that it's positive, so increasing, and it should be more steep than this guy. I probably drew that one a little bit too steep. Okay, I should be getting more steep, and this is going to be 3, right? So that should be even steeper. Okay, so we just draw little line segments that have the correct slope at each dot, okay? When you fill it all in, which technology helps, it looks something like this. And so you can see that slope fields are very useful in predicting weather and other chaotic systems. This is another pretty slope field. This is the Fulton Center in New York City, okay? All right, let's try one. So these oftentimes show up as multiple choice questions. So I'll force a pause on the screen. Can you, actually you go ahead and pause because my forced pause is going to cover the whole screen. So you go ahead and pause and see which question, which answer you like, A, B, C, or D for this one. Okay, let's see what we got. So the correct answer, oh, where did my mouse go? Well, okay. The correct answer is C, okay? What I like to do is, honestly, again, just pick a point. So start at a point. Like at the origin, I can see that I should be getting 0 slope. Okay, so if I plug in 0, 0, I get 1 for this differential equation. I do not get the correct slope of 0, so that can't be it. Also notice for this one that it is independent of y. So for every for every x I pick, then all through that particular x value I should get the same slope. But the point is that doesn't work for me. All right, if I plug in 0, 0, this one's still in the running, right? This one's still in the running, 0 plus 0, 0. This one is a no-go. That's vertical, right? ln of 0, this definitely does not work. I can't take logs of non-positive numbers, so no good there. Again, this doesn't work because I can tell that this changes for x's and y's, and this one's not dependent on y. But again, we could just pick another value. For example, if you pick something in like quadrant 2, will this ever be negative? It's never going to be negative, right? Do you see some negative slopes in here? Yeah, so it can't be that one either, right? So it must be C. So that's how I do the multiple choice. I just start with one point, and that allows me to eliminate, and if it doesn't eliminate enough, I go to another point. All right, so the last thing you might be asked to do with the slope field is to sketch a solution through a particular point. So they might give you a filled out slope field like this, and then they ask you to, okay, you draw the solution curve through the point 0, 1, for example. So I can see, okay, I'm going to start out horizontal, and then I can hit this orange one, and so that's going to move me up. And then I'm just going to keep following these tick marks. Let me show you. I need to do the same thing on the left. So see how I just kind of keep following the general pattern. Again, this is not something that they would like get a ruler out and to measure perfectly, but you're just trying to follow the general path of those tick marks. So as I keep getting to a new x value, what is the slope supposed to be there, and sort of following the general shape. So that's all you're asked to do. That's all you have to do for something like that. Just a general sketch does not have to be perfect. I kind of like to look at it big picture and see, can I see sort of what's going on big picture wise, and sort of see the general shape of the particular solutions there. All right, you all, that's all I have for today. So a couple notes on your homework. Make sure that you are telling me more than just, oh, this is the correct match. So if it's a matching one, like we did the multiple choice one, please either give me a statement of how you know it's the right one or show me points that you checked, that you tried. And again, if you have access to a printer, that would be ideal for this assignment. Otherwise, just be real careful with your graphs. I will see you all next time.